Welcome! This video will provide an overview of AWS container services. You may be thinking, what are containers? Containers are a method of operating system virtualization. Containers are smaller than virtual machines and do not contain an entire operating system. Instead, containers share a virtualized operating system and run as resource-isolated processes. Containers offer several benefits. First, they support repeatability. Additionally, containers deliver environmental consistency because the application's code, configurations, and dependencies are packaged into self-contained environments. Next, they can help ensure that applications deploy quickly, reliably, and consistently, regardless of the deployment environment. Lastly, in terms of space, container images are usually an order of magnitude smaller than virtual machines. Spinning up a container happens in hundreds of milliseconds, resulting in faster launch times than traditional virtual machines. In order to understand containers, it's helpful to know a little bit about Docker. Docker is a software platform that packages software, such as applications, into containers. Docker is installed on each server that will host containers, and it provides simple commands that you can use to build, start, or stop containers. Containers are created from templates called Docker images. Containers have everything that an application that you want to run needs, including libraries, system tools, and the application code, as well as any runtime libraries. Many people who are first introduced to the concept of a container think that the containers are exactly like virtual machines. However, there are some key differences. One significant difference is that virtual machines run directly on a hypervisor, while containers run on any operating system if they have the appropriate kernel features to support Docker host software and the Docker daemon is present. The right of the diagram shows a virtual machine VM-based deployment. Each of the three EC2 instances runs directly on the hypervisor that is provided by the AWS Global Infrastructure. Each EC2 instance is a virtual machine. In this VM-based deployment, each of the three apps runs on its own VM, and each VM provides process isolation. The left of the diagram shows a container-based deployment. Here you see that only one EC2 instance runs a virtual machine. The Docker engine is installed on the Linux guest OS of the EC2 instance, and that there are three containers. In this container-based deployment, each app runs its own container, which provides the process isolation, but all the containers run on a single EC2 instance. The Docker engine is present to manage how the containers interact with the Linux guest OS. And it also provides central management functions throughout the container lifecycle. In an actual container-based deployment, a large EC2 instance could run hundreds of containers. Given what you now know about containers, you could launch one or more Amazon EC2 instances, install Docker on each instance, and manage and run the Docker containers on those Amazon EC2 instances yourself. While that's an option, AWS provides a service called Amazon Elastic Container Service, or Amazon ECS, that simplifies container management. Amazon ECS is a scalable, high-performance container management service that orchestrates the running of Docker containers. It manages the fleet of nodes, or EC2 instances, that run your containers, removing the complexity of managing the infrastructure yourself. Amazon ECS provides a familiar set of features to anyone who uses the EC2 service, including elastic load balancing, security groups, EBS volumes, and IAM roles. Let's look at the role Amazon ECS plays with regards to containers. To prepare your application, you create a task definition, which is considered a blueprint for your application. Task definitions specify details such as which containers should be deployed to run the task. You specify the number of tasks that will run on your cluster, and Amazon ECS Task Scheduler is responsible for placing tasks within your cluster. When Amazon ECS runs the container based on your task, it places them on an ECS cluster. When you choose the EC2 launch type, the cluster consists of a group of EC2 instances, each of which is running an Amazon ECS container agent. In the example here, the Amazon ECS Task Scheduler has received a request to run a task that will require 3 instances of container A and 2 instances of container B. Amazon ECS places these 5 containers on the EC2 instances and the ECS cluster. They're distributed in a way that accounts for the CPU and memory capacity available on the cluster nodes. When you create an Amazon ECS cluster, you need to decide the type of cluster you want. You need to ask yourself, do you want to manage the cluster? If you answer yes, you'll have a more granular control over the cluster, and the cluster will run on EC2 instances that you manage. To manage the cluster yourself, choose either the EC2 Linux plus networking or the EC2 Windows plus networking cluster option. You'll need to specify details about the EC2 instances that will make up your cluster. The same details you specified when launching a standalone EC2 instance. If you don't want to manage the cluster yourself, choose the Create a Networking Only cluster option. Networking only Amazon ECS clusters are powered by AWS Fargate. With the Fargate launch type, the cluster that will run your container will be managed by AWS. With this option, you only need to package your application in containers, specify the CPU and memory requirements, define networking and IAM policies, and launch the application. You do not need to provision, configure, or scale the cluster. It removes the need to choose server types when you decide to scale your clusters or optimize cluster packaging. The Fargate option enables you to focus on designing and building your applications. Next, we'll discuss an alternative container service to Amazon ECS. However, before we begin, it's important to have a general understanding of Kubernetes. Kubernetes is an open source software for container orchestration. Kubernetes enables you to deploy and manage containerized applications at scale. With Kubernetes, you can run any type of containerized application by using the same tool set in both on-premise and your data center, including the cloud. Kubernetes can work with many orchestration containerized technologies, including Docker. Because it is a popular open source project, a large community of developers and companies build extensions, integrations, and plugins that keep the software relevant, resulting in new and in-demand features being added frequently. Kubernetes also automates container provisioning, the networking configuration of containers it deploys and manages, the load distribution of containers, and scaling to handle application load. You may be thinking that you can launch one or more Amazon EC2 instances, install Docker on each instance, then install Kubernetes on the cluster, all while being able to manage the Kubernetes instances yourself. While that is an option, Amazon Elastic Kubernetes Service, or Amazon EKS, significantly simplifies the management of Kubernetes clusters. Amazon EKS makes it easy for you to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control plan. Amazon EKS is certified Kubernetes conformant, so existing applications that run on upstream Kubernetes are compatible with Amazon EKS. It supports Linux and Windows containers, and it's compatible with Kubernetes community tools and many popular add-ons. You may be wondering why Amazon offers both Amazon ECS and Amazon EKS, as they are both capable of orchestrating Docker containers. Well, the reason that both services exist is to provide customers with flexible options. You can decide which option best matches your needs. One challenge of deploying applications on containers is keeping track of storing and managing all those containers. To keep addressing this challenge, AWS provides the Amazon Elastic Container Registry, or Amazon ECR service. It is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. It is integrated with Amazon ECS, so you can store, run, and manage container images for your applications that run on Amazon ECS. When you specify the Amazon ECR repository in your task definition, Amazon ECS will retrieve the appropriate images for your applications. Amazon ECR supports team collaboration, access control, and third-party integration. And it's also possible to use Amazon ECR images with Amazon EKS. Thank you for watching. We'll see you in the next video. Welcome. This video will provide an introduction to the AWS Lambda service. AWS offers many compute options. For example, Amazon EC2 provides virtual machines, while both Amazon ECS and Amazon EKS offer container-based compute services. However, there is another approach to compute that does not require you to provision or manage servers. This third approach is often referred to as serverless computing. AWS Lambda is an event-driven serverless compute service. Lambda enables you to run code without provisioning or managing servers. You create a Lambda function, which is the AWS resource that contains the code that you want to run. You then set the Lambda function to be triggered either on a schedule or in response to an event. Your code only runs when it's triggered. You pay only for the compute time you consume. You are not charged when your code is not running. With Lambda, there are no new languages, tools, or frameworks to learn. Lambda supports multiple programming languages, including Java, Go, PowerShell, Node.js, C#, Python, and Ruby. Lambda completely automates the administration. It manages all the infrastructure to run your code on highly available, fault-tolerant infrastructure, which enables you to focus on building differentiated back-end services. Lambda provides built-in fault tolerance. It maintains compute capacity across multiple availability zones in each region to help protect your code against individual machine failures or data center failures. You can orchestrate multiple Lambda functions for complex or long-running tasks by building workflows with AWS step functions. With step functions in Lambda, you can build stateful, long-running processes for applications and backends. Finally, with Lambda, you pay only for the requests that are served and the compute time that is required to run your code. Billing is metered in increments of 100 milliseconds, which makes it cost-effective to run code on AWS Lambda. Lambda functions are triggered by event sources. An event source can be an AWS service or developer-created application that produces events that trigger the AWS Lambda function to run. Some services, such as Amazon S3 and Amazon CloudWatch events, publish events to Lambda by invoking the Lambda function directly. Other services are pulled by Lambda. For example, Lambda can pull records from an Amazon Simple Queue service, and Lambda can read events from the Amazon DynamoDB database service. Finally, some services, such as Elastic Load Balancing and Amazon API Gateway, can invoke your Lambda function directly. You can also invoke functions directly from the Lambda console or via API, SDK, or the AWS CLI. Direct invocation can be useful, for example, when you are developing a mobile app and want the app to call Lambda functions. AWS Lambda also automatically monitors functions by using Amazon CloudWatch to assist you to troubleshoot failures in a function. Lambda logs all requests handled by your function. Now that you know that a Lambda function is a custom code that you write to process events, and that Lambda runs the Lambda function on your behalf, let's consider how you configure Lambda functions. When you use the AWS Management Console to create a Lambda function, you first give the function a name. Then you specify the runtime environment the function will use. For example, a version of Python or Node.js. You also specify an execution role to grant IAM permission to the function so that it can interact with other AWS services as necessary. Next, you configure the function. Configurations include adding a trigger. You specify one of the available event sources. Add your function code, either by using the provided code editor or uploading a file that contains your code. Specify the memory in megabytes to allocate to your function. Optionally, specify environment variables, such as timeout, the specific VPC to run the function in, and other settings. All of the settings just mentioned end up in a Lambda deployment package, which is a zip archive that contains your function code and dependencies. When you use the Lambda console to author your function, the console manages the package for you. However, if you use the Lambda API to manage functions, you need to create a deployment package yourself. Consider an example use case for a schedule-based Lambda function. Say that you're in a situation where you want to reduce your Amazon EC2 usage. You decide that you want to stop instances at a predefined time, for example, at night when no one is accessing them. And then you want to start the instances back up in the morning before the workday starts. In this situation, you could configure an AWS Lambda and Amazon CloudWatch events to help you accomplish these actions automatically. Here's what happens at each step in the example. First, a CloudWatch event is scheduled to run a Lambda function to stop your EC2 instances at the end of the workday. Second, the Lambda function is triggered and run with the IAM role that gives the function permission to stop the EC2 instances. Third, the EC2 instances enter the stopped state. Fourth, at the start of the workday, a CloudWatch event is scheduled to run a Lambda function to start the EC2 instances. Fifth, the Lambda function is triggered and run. And finally, the EC2 instances enter the running state. Now consider an example use case for an event-driven Lambda function. Suppose you want to create a thumbnail for each image file that's uploaded to an S3 bucket. To build a solution, you create a Lambda function that Amazon S3 invokes when objects are uploaded. The Lambda function reads the image object from the source bucket and creates a thumbnail image in a target bucket. AWS Lambda has some limits that you should know about. First, Lambda limits the amount of compute and storage resources you can use to run and store functions. Lambda also limits you to 1,000 concurrent invocations in a region. Lambda functions can be configured to run up to 15 minutes at a time. You can set the timeout to any value between 1 second and 15 minutes. There is a 250 megabyte limit on the deployment package size of a Lambda function. A layer is a zip archive that contains libraries or other dependencies. With layers, you can use libraries in your function without needing to include them in your deployment package. Limits are either soft or hard. Soft limits can potentially be relaxed by submitting a support ticket and providing justification for the request. Hard limits cannot be increased. Thanks for watching. We'll see you in the next video.
Welcome. In this video, we'll provide an introduction to the AWS Elastic Beanstalk service. Elastic Beanstalk is another AWS Compute Service option. It provides an easy way to get web applications up and running on the AWS cloud. AWS Elastic Beanstalk automatically handles infrastructure provisioning and configuration, deployment, load balancing, automatic scaling, health monitoring, analysis and debugging, and logging. You upload your code and Elastic Beanstalk automatically handles the deployment, from capacity provisioning to load balancing to automatic scaling and monitoring and application health. When you use AWS Elastic Beanstalk, you retain full control over the AWS resources that power your application, and you can choose to access the underlying resources at any time. There is no additional charge for AWS Elastic Beanstalk. You only pay for the AWS resources, such as EC2 or S3 buckets, that you create and store and run your application on. You only pay for what you use as you use it. AWS Elastic Beanstalk enables you to deploy your code through the AWS Management Console. the AWS command line interface, Visual Studio, or Eclipse. It supports a broad range of platforms, including Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. Elastic Beanstalk provides all the application services that you need for your application. The only thing you must create is your code. AWS Elastic Beanstalk deploys your code on several popular application web servers. In summary, Elastic Beanstalk is fast and simple to start using. You use the AWS Management Console, a Git repository, or an IDE such as Eclipse or Visual Studio to upload your application. You can improve developer productivity by focusing on writing code instead of managing and configuring servers, databases, load balancers, firewalls, and networks. Elastic Beanstalk is also difficult to outgrow. Your application can handle peaks in workload or traffic. It automatically scales your application up and down based on your application's specific needs by using easily adjustable automatic scaling settings. You can even use CPU utilization metrics to trigger automatic scaling actions. Finally, you have the freedom to select the AWS resources, such as Amazon EC2 instance type, that are optimal for your application. Elastic Beanstalk enables you to retain full control over the AWS resources that power your application. If you decide that you want to take over some or all of the elements of your infrastructure, you can do so by using the management capabilities that are provided by Elastic Beanstalk. Thank you for watching. We'll see you in the next video. Welcome back. It's time to review the compute module and wrap up with a practice certification exam question. In this module, you learned how to provide an overview of different AWS compute services in the cloud. You demonstrate when to use Amazon Elastic Compute Cloud, Amazon EC2, identify the functionality in the Amazon EC2 console, perform basic functions in Amazon EC2 to build a virtual computing environment, identify Amazon EC2 cost optimization elements, demonstrate when to use AWS Elastic Beanstalk, demonstrate when to use AWS Lambda, identify how to run containerized applications in a cluster of managed servers. Now let's look at a sample certification question. Which AWS service helps developers quickly deploy resources which can make use of different programming languages such as .NET and Java? The key words from this question is to recognize developers quickly deploy resources, which indicates that the focus of the question is about providing developers with a way to deploy applications quickly. Different programming languages, which is identified as the key phrase that describes the use case for how developers want to use the AWS resources. By identifying the key components the developers needed to use, we can determine that the correct answer is C, AWS Elastic Beanstalk. The ability for the developers to quickly deploy AWS infrastructure for their applications increases the developers' productivity, as they only need to focus on writing the code for the application and not provisioning or managing the underlying infrastructure. Thanks for watching.
Welcome. This module will cover AWS storage services. Cloud storage is typically more reliable, scalable, and secure than traditional on-premise storage systems. Cloud storage is a critical component of cloud computing because it holds the information that applications use. Big data analytics, data warehouses, the Internet of Things, databases, and backup and archive applications all rely on some form of data storage architecture. In this module, we will review the following AWS storage services: Amazon Elastic Block Store, known as Amazon EBS, Amazon Simple Storage Service, known as Amazon S3, Amazon Elastic File System, Amazon EFS, and Amazon Simple Storage Service Glacier. The goal of this module is to learn how to describe key concepts for AWS storage. You will learn about the different types of storage resources and review pricing options that affect the cost of storage. After completing this module, you should be able to identify the different types of storage, explain and describe the functionality of Amazon Simple Storage Service, Amazon Elastic Block Store, Amazon Elastic File System, and Amazon Simple Storage Service Glacier. Thanks for watching. We'll see you in the next video. Welcome. This video will cover Amazon Elastic Block Store, or Amazon EBS. Amazon EBS provides persistent block storage volumes for use with Amazon EC2 instances. Persistent storage is any data storage device that retains data after power to that device is shut off. It is also called non-volatile storage. Each Amazon EBS volume is automatically replicated within its availability zone to protect you from component failure. It is designed for high availability and durability. Amazon EBS volumes provide the consistent and low latency performance that is needed to run your workloads. With Amazon EBS, you can scale your usage up or down within minutes, while paying a low price for only what you provision. One critical difference between storage types is whether they offer block-level storage or object-level storage. This diagram illustrates the difference. What happens if you want to change one character in a 1 GB file? With block storage, you change only the block that contains the character. With object storage, you have to update the entire file. This difference has a major effect on the throughput, latency, and cost of your storage solution. Block storage solutions are typically faster and use less bandwidth, but they can cost more than object-level storage. With Amazon EBS, you can create individual storage volumes and attach them to an Amazon EC2 instance. Amazon EBS offers durable, detachable, block-level storage for your Amazon EC2 instances. Because they are directly attached to the instances, they can provide low latency between where the data is stored and where it might be used on the instance. This low latency makes EBS a good choice for running a database on an Amazon EC2 instance. A backup of an Amazon EBS volume is called a snapshot. The first snapshot is called the baseline snapshot. Any other snapshot after the baseline captures only what is different from the previous snapshot. Some typical uses of Amazon EBS volumes are boot volumes and storage for Amazon EC2 instances, such as a file system for data storage, database hosts, or storage for enterprise applications. You can reduce your storage costs by selecting the type of storage that is the best match for your workload. Provisioned IOPS SSD-backed Amazon EBS volumes can give you the highest performance. However, if your application doesn't require or won't use performance that high, general purpose SSD might be sufficient. The lower cost option might be a solution for additional storage or use cases other than boot volumes. You can use Amazon EBS volumes as primary storage for data that requires frequent updates, such as the system drive for an instance or storage for a database application. You can also use them for throughput-intensive applications that perform continuous disk scans. Only SSDs can be used as boot volumes for EC2 instances. To provide an even higher level of data durability, with Amazon EBS, you can create point-in-time snapshots of your volumes, and you can recreate a new volume from a snapshot at any time. You can also share snapshots or even copy snapshots to different AWS regions for even greater disaster recovery protection. For example, you can share your snapshots from Virginia in the United States to Tokyo, Japan. You can also encrypt Amazon EBS volumes at no additional cost, so the data is encrypted as it is in transit. As your company grows, the amount of data stored on your Amazon EBS volumes is also likely to grow. Amazon EBS volumes can increase capacity and change to different types, so you can change from the hard disk drives to solid-state drives, or increase from a 50 GB volume to a 16 TB volume. You can do this resize operation dynamically without needing to stop the instances. Here are some important things to keep in mind when you estimate the cost for Amazon EBS. Storage for all Amazon EBS volume types is charged by the amount you provision in gigabytes per month until you release the storage. Input-output is included in the price of general-purpose SSD volumes. However, for Amazon EBS magnetic volumes, I/O is charged by the number of requests that you make to your volume. With provisioned IOPS SSD volumes, You are also charged by the amount you provision in IOPS multiplied by the percentage of